Hi, this is Fazana again. Welcome to part 4 of the circle theorems. In this video, we'll look at some more circle theorem questions. As important as the circle theorems themselves, remember, mark your radii. The minute you mark your radii, which my marker doesn't work, you can see the isosceles triangles, yeah? Because without your isosceles triangles, it doesn't matter how well you know your circle theorems, your workings will just collapse. Yeah, all right, so always just mark your radii. Okay, let's have a look at the questions. The diagram shows a cyclic quadrilateral. Okay, so what do we know about cyclic quadrilaterals? Opposite angles add up to 180, so that's your cyclic quadrilateral. Yeah. Okay, so you can see that 3x and the 9x, so 3x plus 9x equal 180, yeah? So 12x equals 180 divided by 12, so x equals 15. All right, yeah? Okay, so that's 45. And that's 9 times 15 is 135. And while we're at it, the 2x comes to 30. All right? Oh, if you look at that triangle, can you see this diagram is just full of triangles? So just keep trying to locate triangles, yeah? And you know they add up to 180. So that one must be 15. All right? Yeah? Okay, straight lines BA and CD are extended and meet at E. Okay, so it's got nothing to do about two tangents meeting a point. There's no tangents here. Yeah? Okay, EA equals AC. So we have an isosceles triangle here. So if that's 15, that's 15. Yeah? And one thing I've noticed when I'm looking at this triangle, if that is 135, then angles on a straight line, that would be 45. Okay? Oh, while we're at it, that will be 120. 60, 120. Okay? Yeah? All right. ADC 9x, DAC 2x, show that x is 15. Oh my god, we've already done that one. Yeah? It feels so good, doesn't it? Calculate the size of angle EAD. Okay, where's that? EAD. Oh my god, we've already got, looks like lead. 120. Yeah, all right. How did we get it? What we did is, first let's talk about this angle. Angle AED equals 15. And why was that? Is because triangle ACE is isosceles. Yeah. Okay, and then that angle there, angle ADE equals 45. And reasons for that, angles, and I'm taking real shortcuts here, but you've got to write angles on a straight line equal 180. Yeah, and then angle EAD equals 120, and angles in triangle equal 180. All right, yeah, that was all right, wasn't it? Cool, very good. Just keep marking as much as you can, and as I said, chances are, as long as you know your theorems, as long as you're, sort of reading every word here and there, you're sort of picking up things, and then the diagram becomes your own. Yeah, all right, cool. Okay, next question. ABC is a cyclic quadrilateral. Okay, we have a lot of those. Cyclic quadrilateral. So you know those two angles will be 180, and those two angles will be 180. Yeah, all right. PAQ is a tangent. So the minute I see the tangent, there's no radius meet tangent. The alternate segment. Yeah. So can you see there's this triangle here? So if that's 32, then that is going to be 32. Okay. So angles in the alternate segment, and we might as well just write it there. So angle ADB equals 32. And again, I'm taking a shortcut, but you've got to write the whole thing. Alternate segment. So you've got to write the angle between the tangent and the chord is equal to the angle in the alternate segment. Okay, yeah. So that was what they gave the tangent for. BC equals CD. So BC equals CD, so that's an isosceles triangle. AD is parallel to BC. Okay, so what I do, anytime I have parallel lines, I just sort of extend them, and then chances are I can see an F, a corresponding angle, a Z, an alternate angle. So here, can you see your alternate angle there? So that is 32. So that is 32. And then 180 minus 2 lots of 32, 64 equals 116. Okay, so that is 116. All right, okay. Find the size of angle BAD. So BAD, okay, that one there. Yeah? Okay, the minute you sort of mark it and, you know, look at it and just keep saying, okay, I want to find you, I want to find you, you can see cyclic quadrilateral, so they'll add up to 180. So that will be the 64. Yeah, quick calculation there. Yeah, all right. Okay, so let's continue. So we found that angle there. And so we say angle CBD is also 32. And we go alternate angle to angle ADB. Yeah, okay, and so we found that, and then we go angle BCD equals 116, and then we go triangle BCD is isosceles, and angle BAD equals 64, opposite angles in cyclic quad. No, you have to write the quadrilateral. Yeah, add up to 180. Okay, yeah, all right, good. Okay, A, B, C, and D are 4 points on the circumference of the circle. Yet again, we have a cyclic quadrilateral. Yeah, so can you see A, B, C, and D? Yeah, so you know that and that will add up to 180, and that will add up to 180. Yeah, okay. ABE and DCE are straight lines. Okay, so if that's a straight line, oh my god, that's why they gave us that. So that bit is 120. Okay, and the cyclic quadrilateral, so if that's 120, then those two together will be 60. Yeah, all right, so that's what that was about. Angle BAC is 25. Now, it looks like, can you see, if you look at that arc there, you've got your bow tie there, yeah? So can you see that would also be 25? Yeah? If that's 60 and that's 25, then that will be 35. All right, yeah. Okay, so now you know why they gave us the 60, you know why they gave us the 25, yeah? Find the size of angle ADC. So ADC is 60. Okay, and as I said, you would write that first. That is angle 120 because angle's on a straight line, and then you would say why that angle is 60 because angle's in a cyclic quadrilateral. Yeah, so that would be straight line, and that would be cyclic quad. Okay, yeah. Okay, find the size of angle ADB. So we've got ADB, so that is 35. And then first you have to say why that's 25. So the reason that's 25 is angles extended by same arc. Yeah. And then you say the 60 minus the 25 equals 35. All right, okay, but you write it neatly, just the way I said, yeah? You write it and then put the circle theorems in brackets, okay? Angle CAD equals 65, so CAD, that's 65. Okay, 65 plus 25, so that whole thing is 90 degrees, yeah? Okay, Ben says that BD is a diameter. Is he correct? Yes, he is. And the reason why is because angle extended by diameter equals 90 degrees. All right, yeah, okay. There's so much in that diagram, you know, you could sort of play around with it and have all the answers there before you hit the questions, yeah? Especially like most of them, yeah? Chances are you'll get all of them before you hit the question. All right. Okay, P, Q, and T are points on the circumference of a circle, center O. Okay, so we've looked at that center O, and we know radius meets tangent. So 90 minus 58 is 32. Yeah? Okay, and we can see that's an isosceles, but we can't do anything with it yet. But what I also see when I see a tangent is there's a triangle there. So it's the alternate segment. So if that's 58, that means that's 58. Okay? Yeah? So that 32 is radius meets tangent. The reason that's 58 is alternate segment. Okay, and then we've got this isosceles triangle. So you've got 180 minus 58 equals 122. Yeah, and then when we go 122 divided by 2, we get 61. Okay, so those will be 61. That whole thing there. Yeah, 61. And then the reason you say why that is 61 is because triangle QPT isosceles. Yeah, okay. The line ATP is the tangent, we saw that. PQ equals TQ, yes, we've got the isosceles. That's 58. Calculate the size of angle OTQ. So OTQ. So we need that bit there. Okay, and that bit there is just the full 61 minus the 32, which is 29. All right, yeah, okay. That was a good question, wasn't it? Yeah. It says give a reason for each stage in your working. Yeah. So that was our first stage. As I said, you need to write it a bit neater. Yeah. So you say angle OTP is 32 in brackets radius meets tangent. Angle PQT equals 58. Angles between the tangent and the chord. Yeah. Alternate segment. And then talk about that being 61 because that triangle is isosceles, and the fact that we got that 61 there and then minus the 32 is 29. All right, yes, good. Okay, P, Q, R, and S. Oh my god, that's a complicated drawing there, isn't there? Yeah. Okay, a point on the circumference of a circle center. Oh, okay, so what can I do about this center bit first? Okay, the center bit there, you can see radius meets tangent there. So that's 58, so that must be 32. Yeah, all right. I'm seeing this bow tie here, but it's not the angles extended by the same arc. It's angle at the center of the circle is twice the angle at the circumference, so that is 32. Yeah, all right. Was that good? Okay. All right, let's go for it. Is there anything else we can see? Oh yeah. If that's 58, then can you see you've got that triangle there? So that's 58, but that didn't make sense because, oh yeah, that's not our arrowhead, is it? Yeah, so it looks a bit confusing. So that's 58. Yeah, so that's your alternate segment. Okay. All right, so let's just write your explanations. So that one is radius meets tangent. That's angle at center twice angle at circumference. That one there is alternate segment. Okay, yeah. Okay, T is a tangent, we got that. And then they gave us the angles, and now we know exactly why they gave us that angle and why they gave us that angle. Find the size of angle OSQ. Can you see when we do that, we think, oh, I've got most of them, if not all. Yeah. So OSQ, OSQ, so that's 32. Okay. SQR, SQR is 32 as well. QPS, QPS is 58. QRS, so QRS. Oh, okay, so we need to draw that line there. Yeah. Okay, now what would that be? Any idea? Oh, look. The minute I draw that, can you see you've got your cyclic quadrilateral? So that whole angle there is 180 minus the 58, so that's 122. Yeah, and that's cyclic quad. Yeah, so that if that's 122 and that's 32, then that angle there is that what they're asking? QRS? Oh, QRS. So that's the 122. Yeah, so that's our cyclic quadrilateral. And it says, why are the lines QR and OS parallel? And the reason they are parallel, you can see that line there is parallel to that line there. And the reason why is, can you see the Z? Yeah? So you say angle RQS and angle RSO equals 32 alternate angles. Right? Okay, find the size of angle QRO. QRO. So we're looking for that bit there. Yeah? And again, it's to do with the parallel lines. So you can see your Z there. So that must be 64. And QSR. So QSR. So that one there. So that is 180 minus the 32 plus the 122, and that comes to 154. So 180 minus 154 is 26. Okay. That was very intense, but can you see there's just so much in there and it's really good to learn it all. Yeah? Okay. So just keep doing this. If you can find any of these angles, then you can see you're just mastering circle theorems. Yeah? So it's a real good question to sort of work through. Yeah? All right, that's all for now. I hope that was fun. Now please watch part 5 and you will be a master of circle theorems. And of course I'll be uploading a part 6 at some point. Don't worry, I'm with you every step of the way, helping, inspiring, and pushing. Just a bit. Okay, remember, you're in control. Take care. Until next time. Bye.